In our previous lesson, we learned about the Nebulae Hypothesis, which scientists use to explain how our solar system was formed. According to the Nebula Hypothesis, our solar system was formed from a nebula, which is a swirling collection of dust and gas, by a process known as accretion. Accretion is the gradual addition of new material. Gravity caused the dust and gas to accrete, creating first the sun and then later the planets. So here's my question. What evidence do scientists have of the Nebula Hypothesis? How do they know that our solar system formed from dust and gas that accreted into planets like Earth? One of the most important pieces of evidence that scientists use to support the Nebula Hypothesis are impact craters. So what are impact craters? Impact craters are craters on a planet or moon caused by the impact of a meteorite or other object. Typically, impact craters are circular with a raised rim, as you can see in this picture here. So how are impact craters evidence for the Nebula Hypothesis? Well, let's find out. Well, when you think about it, if the solar system formed by accretion, the early solar system would have been filled with lots of rocks and dust swirling around. Because remember, it was the rocks and dust swirling around that formed the planets. So there still would have been a lot of rocks and dust swirling around while the solar system was being formed. Now these rocks, called meteorites, must have occasionally crashed into the planets, leaving impact craters. Thus, if we find impact craters on planets and other rocky bodies like the moon, this will provide evidence to support the theory that planets were formed by accretion. So let's look for evidence of impact craters on 3 terrestrial or rocky bodies close to Earth: the Moon, Mercury, and Mars. Here are 2 images of the Moon. You have one full image of one side of the Moon and a close-up. Would you say, looking at this image, that there's evidence of impact craters on the Moon? Now let's take a look at Mercury. Once again, we have a full image of one side of Mercury and then 2 close-up images. Looking at these images, would you say there is evidence of impact craters on Mercury? Now let's take a look at Mars. Once again, we have an image of a full side of Mars, and then we have a couple of close-up images. And indeed, this close-up image corresponds to this section on Mars as indicated by the red arrow. Would you say there's evidence of impact craters on Mars? As you can see from the previous images, all 3 terrestrial bodies, the Moon, Mercury, and Mars, all have evidence of impact craters on their surface. Well, what about Earth? Let's take a look. Here we have an image of Earth with the clouds removed just to make it a little bit easier to see. Based on this image, would you say that there is evidence of impact craters on Earth? As you can see from the previous image, it's hard to see evidence of impact craters on Earth. However, if the Moon, Mercury, and Mars have experienced frequent bombardment by objects from space in their past, do you think it's likely that Earth also experienced a similar type of bombardment, judging how close the Earth is to these other bodies? As you remember, the Moon is fairly close to Earth compared to all other bodies. Mars is the planet next to Earth, and Mercury is one planet away from Earth. So between Earth and Mercury, there's Venus. So once again, do you think it's likely that Earth also experienced a similar type of bombardment, judging by how close the Earth is to these other bodies? Even though Earth does not have as many impact craters or visible impact craters as the Moon or Mercury and Mars, there are some impressive impact craters on Earth. Take a moment to explore this website and learn about some impressive impact craters on Earth. Let's see what you found out. So here we have an image of the Behringer Crater in Arizona. How deep is the Behringer Crater? If you need to, pause the video and go back to that website to find the answer. Now we have the Matakugan crater in Quebec, Canada, and it's the largest visible impact crater in the world. The crater is a multiple ring structure about 100 kilometers across with a 70-meter diameter inner ring, and is thought to have been formed by a meteorite with a blank kilometer diameter. So what was the diameter of the meteorite believed to have formed the Matakugan crater? The Aronga Crater is the largest visible impact crater in the world and estimated to be 345 million years old. Where is it located? This crater, located on the Estonia island of Saaremaa, is one of the youngest impact craters in the world and is estimated to have formed 7,600 years ago. What is the name of this crater? Now that we've looked at a bunch of visible craters that we can find on Earth, let's think about why does the Earth have relatively few obvious impacts, especially when you compare it to something like the Moon, which is so close by. Well, the reason the Earth doesn't have as many obvious impacts is because the Earth's surface is constantly changing. And there are two processes that causes the Earth's surface to change constantly. The first is tectonic processes. Now, we're going to learn more about that later on in this unit. But here are some key words that are associated with tectonic processes: continental drift, mountain forming, volcanism, trench building, faults, and the rock cycle. You've probably heard of some of these terms before, and tectonic processes have to do with the movement of the Earth's tectonic plates. The next type is surface processes. And again, you probably would have heard of some of these words like erosion, deposition, weathering, rock cycle, etc. These surface processes only occur at the surface. So all of the changes occur at the surface, whereas with tectonic processes, they also involve the inner layers of the Earth. But in either case, the key is that the Earth's surface is constantly changing, and as a result, impact craters that may have once been visible on Earth may no longer be visible due to Earth's changing surface. So now let's summarize everything we've learned here. Here is a summary, and you're going to use the words in the word bank, which are listed in alphabetical order, these words being accretion, gravity, impact, meteorites, and planets, to fill in the blank. Let's begin. Scientists use blank craters as evidence that the Earth and other planets formed by blank as described by the Nebula Hypothesis. According to this theory, planets were formed as dust pulled together by blank formed large rocks and eventually planets. Impact craters show that the early solar system still had lots of rocks, called blank, swirling around that crashed into terrestrial bodies like the planets and the Moon. Although it is easy to see lots of impact craters on other planets and the Moon, it is harder to see impact craters on Earth due to tectonic and surface processes. which change our planet's surface. Therefore, scientists rely on impact crater evidence on other blank and the moon, in addition to limited number of visible impact craters on Earth, as evidence to support the theory of nebula hypotheses. Take a moment to fill in these blanks, once again using the words in the word bank. So that's the end of this presentation on how impact craters are evidence for the nebula hypotheses. Before you end this presentation, please make sure that you rate your understanding and list any questions that you have. Have a quality day.